Hi, we are Team Tinkerers and we come from MIT Manipal and we are building a smart energy solution. So, 3,000 deaths, 70 million people affected, all due to one problem, which is grid failure. And all this could have been prevented by one small solution that we are building. It is called LIFE. LIFE is localized intelligence for energy.
So coming to our solution, we have four main features. So right now in present market, the controllers which are used to charge solar battery is very dumb. They are very dumb. So they give constant current output and balance charge the batteries. What we are doing is we are prioritizing two things: battery health and state of charge of the battery. Imagine you come to your home and the weather is bad and your battery is not charged because the weather was bad and the solar output was not enough to charge your battery. Think of it now like that we could have fast charge the battery, and when we reach home we get a 100% charged battery. That's exactly what we are doing. We have a ESP-C3 on board, which and with the LDR and DHT11 sensor. DHT11 takes temperature and humidity, and the LDR recognizes the light. So we are trying to get the environment conditions, and on basis of that we'll either fast charge or slow charge the battery. It also acts as our whole system also acts as a fault detection and maintenance system which detects faults. It can be any leakage current on a metal, it can be soiling on a solar panel. So small faults which can actually accumulate and give a very degraded power output, you can solve. There is actually a app we made for the user. It has all the details from sunlight, heat, comfort, air moisture, what the signatures that we are getting, power signatures. It has alerts for any fault it detects. Also, it has care tasks. So exactly what is happening in the ESP-C3 is that we get the data from the weather API, we get the data from the sensors, we sensor fuse them and send it to server AI. Server AI takes decision between whether to fast charge the battery or slow charge the battery depending on the weather conditions. That's exactly what we are doing. So coming to the later parts, so this whole hardware acts as one node, one smart node for the solar power charging. Imagine multiple nodes like this installed in different buildings, which can talk to each other and share power if they need it, or if any battery is drained, basically underload or overload conditions. If I have like a event to go, like event to organize, and I have very low battery on my system, I can ask for power from different nodes. So we made a whole balance system which works on RL. So this is our hardware node which talks to other digital twins. In the simulation, I can toggle here overload and underload conditions. So what RL will try to do is RL will try to minimize. So I just changed like state of charge and load conditions for a particular node. So now it will try to minimize the transmission losses, and it will try to map the power in a certain way so that transmission losses can be minimized, and whichever node is power deficient can get enough power from the surplus node. So that's exactly what we are doing. We plan in future to talk to companies because we want to do everything on edge. We want to skip the cloud because we are trying pulling a server AI right now, which may require internet. So we want to do that on the hardware itself. So companies which are coming with NPUs and edge AI chips, we want to integrate that in our hardware right now. Our customer is again whichever user which has solar power installed in their houses, companies, any building. That's our end-to-end customer. So yeah, that's it. Thank you.
Very cool. Very cool.